Good morning, students. And today I will teach new chapters. Okay, happily portion chapters and complex numbers. Okay, you will get your portion. Okay, then most probably I am telling complex numbers are there, certain relation. Okay, and limit, continuity, hmm, and equation of straight line, and section B and section C also. Okay. Section A, all of you know there is parabola, hyperbola, ellipse. Okay. And statistics is section C. Okay. And option is there. You have to attempt in either section B or section C. Okay. And section A 65 marks. Section A 65 marks. And section B or section C 15 marks. Total full marks 80 and remaining 20 marks project. Okay. And project also I will discuss. Okay. And I will give the study material. And I will discuss, I will take on extra class for project. Okay. Now I am discussing now complex number. Achha, all of you know real number. What is real number? A number whose square is always positive. No? Real number. See, what is real number? Now I am adding complex number. Okay. Now real number denoted by the symbol R. So what is real number? A number whose square is always positive. A number whose square is always positive is called real number. Okay. Suppose I am writing, say, root over 3. Okay. And its square, suppose root 3 whole square, no? So always 3. If you write only 3 right, the whole square, so it will be 9 minus 3, its whole square, that is minus 3 whole square, 9. If we write minus root 3, its whole square, see, there will be only minus 3. Okay, minus 3. So, its square is positive and its square is also positive. Minus 3 whole square is also positive. So here root over 3 is a real number. Only 3 also real number. Minus 3 is also real number. But root of minus 3, no. It is not a real number. Because see, look at here, its square is negative. Its square is negative. Okay. So it is not a real number. Okay. Then what type of number is there? Say, I am writing, look at here. See, root under minus 3. So we can write here minus 1 into 3. Okay. So minus 1 into root over 3. We can write now. So here this value we know, we denoted by the symbol root under minus 1, I equal to root under minus 1. Okay. So root over 3 into I, where I is imaginary number, where I is an imaginary number whose value is root under minus 1. Okay. So if you write I square, keep in mind various type of power. I square minus 1, I cube I square into I, that is minus I. Okay, I to the power 4, so write I square into I square, that is minus 1 into minus 1, that is 1. So all of you remember the various type of powers. Various type of powers. I square minus 1, I cube minus I to the power 4, I square into I square. Okay, that is 1. Now suppose we have to consider two real number, say x and y belongs to R, two real number. If you can write, suppose x plus iy form, x plus iy form, where both x and y real, x is imaginary, x is real part, here x real part and y imaginary part. Okay, then x plus iy form, x plus iy form where I equal to root under minus 1 is known as complex number. Okay, x plus iy is known as complex number. It's denoted by the symbol z. So write z equal to x plus iy. Okay, is called complex number. Complex number where x and y both real, x and y belongs to R, and x is called real part. Okay, x is real part and y is imaginary part. Imaginary part. Note it down. Okay, x plus iy z equal to x plus iy called complex number. xy belongs to R, real number. X is a real part, y is imaginary part. Note it down, hurry up. Okay, now see, so z x plus iy is a complex number. Okay, now here the 2 points. Suppose here x and y, no, x is called abscissa, y is called ordinate. Suppose you are drawing two axes here. Suppose x axis, x so x dash, y o y dash. Okay, see, take any point P of x, y, draw perpendicular PA. This is joint origin O. So this is X, this is Y. Here Z. Listen one thing. This axis X, so X dash is known as here real axis, and this plane is known as complex plane or argon plane. Keep it in mind, argon plane. Argon plane you have right, or complex plane. Okay. Here 2 point X and Y. So X, so X, this one is known as real axis, and Y O Y dash is called imaginary axis. Okay. Suppose here X and Y is there. So this distance, if we consider this is suppose R, then R square saman X square plus Y square. So R you have to write root under X square plus Y square. You are taking only positive value. Okay. You are taking only positive value. Then this value is known as modulus of a complex number. Z equal to X plus IY. Then its mod, that is mod Z equal to root under X square plus Y square. Okay. So mod Z is denoted by the symbol like that. See, mod Z. Okay, so this will be root under X square plus Y square. Okay, root under X square plus Y square. Suppose again, if the point is here, that's why suppose I am writing, look at here. The point, so I am taking here. Again, see, the coordinate is there, suppose is a minus X, this is Y. The point minus X comma Y, no? Okay, that Z equal to here minus X plus IY complex. Okay, then here also we are getting R equal to root under X square plus Y square. Again, if you take the point here, that side, see, look at here. So minus X minus Y. So the Z equal to minus X minus IY. Here also you are getting root under X square plus Y square. Similar, we put it that side, see. So point is here also minus X, sorry, this is X minus IY. Z. Okay, complex number 4. So here X minus IY, see, look at here. Here X plus IY. Here is X minus IY. But distance no change. This will be always X square plus Y square. Okay. And Z equal to X plus IY. Then you can write here X minus IY is conjugate complex number. If Z equal to X plus IY, then Z bar X minus IY. Keep in mind that it's conjugate complex number. It's conjugate complex number. Okay, here. Now, if we draw a curve, suppose the locus of the point, see, what is the locus of the point? In complex plane, the point P, that is complex number Z, lie on a circle. No? If you draw here, see like that, so the curve is here, like that. We are getting one circle is there. Okay, like a circle is there. So in complex plane, the point P lie on a circle. Understood? Because the distance is always same. Okay. Now, so here in complex, that is Z equal to X plus IY. Wait. See. So Z equal to X plus IY is a complex number. Then Z bar is known as x minus iy will be conjugate complex number, okay? And modulus z root under x square plus y square, okay? Modulus z. And mod z bar, it is always also x square plus y square. So you can write mod z equal to mod z bar, no? See, mod z equal to mod z bar. Yeah, this is no change. This is always same. Okay. Now, so here again, similar right here. Suppose this is x-axis. Already discussed on this one, y, o, y dash. Okay, real axis. This is imaginary axis. Take another point. Suppose p, x, and y. Now join PM. This is suppose theta. This is called theta. So this is x, this is y. You know? Okay. So the distance is r. So y equal to sine theta. All of you know y by r. Then y equal to r sine theta. Okay. And cos theta equal to x by r. Then x equal to r cos theta, and tan theta equal to y by x. Okay. Then theta, we can write this theta. Okay. So theta we can write tan inverse y by x. This is don't say this is -1. It's wrong. So it will be inverse function. One function is there, tan inverse x, whole part is represents, and that is angle and angle. Okay, so theta tan equal to tan inverse y by x. It is a multi-valued function. Okay, multi-valued function, many-valued function. For one value of x or y, we will get one value. Suppose tan inverse 1, tan inverse root 3. Okay, so we will get many values of theta. Understood? So that is why this is known as many valued function. Okay, so here tan theta, that is theta, is called argument or amplitude of a complex number, which is represents as tan inverse y by x, or tan theta equal to y by x. Okay, in complex number, then tan theta is known as argument or amplitude. Keep in mind, argument or amplitude. Okay. Okay. Now, so we know z equal to x plus iy is a complex number. No. See, look at here. So z, x equal to r cos theta plus y equal to r sin theta. Then you take common r, then cos theta plus I sin theta. Then it is known as z equal to r into cos theta plus I sin theta. So it is known as modulus amplitude form of a complex number. Modulus mod amplitude form, okay, of a complex number. Suppose one complex number is given, okay, convert into modulus amplitude form. First we have to find out the value of r. Okay, first find out the value of r, that is modulus, then find out theta. Okay, so it will be known as modulus amplitude form. Okay. Now again, suppose Z1 and Z2 be two complex number, okay, complex number. Then mod Z1 Z2 always equal to, keep in mind, Z1 mod into Z2 mod, okay, and Z1 by Z2 mod, you can write Z1 mod by Z2 mod separate, Z1 mod by Z2 mod. A Z1 plus Z2 mod always less or equal to mod Z1 plus mod Z2, and Z1 minus Z2 mod always greater than or equal to Z1 mod minus Z2 mod, okay, whole of mod, okay. Similar way, amplitude, then amplitude Z1 Z2 always equal to amplitude of Z1 plus amplitude of Z2, okay, and amplitude of Z1 by Z2, so you can write here amplitude of Z1 minus amplitude of Z2. The students, keep in mind here, suppose Z equal to x plus iy, okay, then tan theta y by x, that is argument or amplitude known as theta. So write theta, we know tan inverse y by x, okay. Now whatever the value is there, that is minus pi is principal value is there, okay. So minus pi less or equal to theta less or equal to pi, this is known as principal in that interval, okay, maybe equal, okay. So here less than or equal to pi, or this one you can write, okay. So here in that value the amplitude or argument lie between these two, okay. So less than pi or greater than minus pi, this is the principal value of argument or amplitude, okay. Suppose first quadrant, second quadrant, third quadrant is there, then how to find the amplitude? Wait, I am explaining here, look at here. See, suppose Z equal to 1 plus I given, then its modular Z will be, mod Z will be root under 1 square plus 1 square, that is equal to 2, okay. Now amplitude Z, okay. See here, if you consider this is Z equal to x plus iy, then x equal to 1, y equal to 1, no? Then the point 1, 1 lies on first quadrant. The point 1, 1, both are 1, 1 point is there, lie on first quadrant. Now, if the principal value of theta, argument be theta, then we can write tan theta equal to y by x. So it will be 1, 1 can be tan 45 degree. Then theta will be pi by 4 or 45 degree. We can write, no? See, first quadrant, keep in mind, now first quadrant range is there for first quadrant, okay. The range 0 less than theta less than pi by 2, 90 degree, keep in mind. Argument, the principal value of argument, theta, tan theta, that is theta values lie between 0 to 90 degree. And second quadrant, for second quadrant in mind, 90 degree less than theta less than 180 degree, okay. And for third quadrant, keep in mind, is there minus 180 degree less than theta less than minus 90 degree, that's interchange, negative sign. And fourth quadrant is there, so here minus 90 degree less than theta less than 0 degree, okay. All of you remember this part only. If you remember, you can easily solve, that is argument of complex number or amplitude of complex number, you can easily solve. Okay? Note it down. So its argument is there. Again, suppose z equal to -1 minus I. So here x equal to -1, y also -1. So tan theta equal to y by x. So -1 by -1 is 1. Okay. So if you write theta equal to 45 degree, it is completely wrong. Because look at here, third quadrant range is there. Both negative, both minus minus. The point lie on third quadrant. Understood? So if you write this is 45 degree argument, then completely wrong. Understood? Then how to find? Look at here. See, tan theta y by a, that is 1 is there. Okay. So write tan 45 degree first. Then this 45 you can write no tan 180 degree minus 135 degree you can write. Now this will be tan 180 minus theta minus tan theta. Okay. So write tan, this for again 135 degree. Okay. So tan theta. Then theta equal to minus 135. See, minus 135 degree is there. Look at here, third quadrant range is there. So argument or amplitude of z, that is -1 minus I. So it will be minus 135. Okay. Okay, my dear students. Again, next I will discuss